I'd like to work through a couple of examples of each of the conversions, going from degrees to radians and then going from radians to degrees. Before we do that, you should have committed, before you attempt any of these sorts of questions, you should have committed to memory what is the way of doing the conversion. You may have committed to memory this little schema. So to go from radians to degrees, you multiply by 180 over pi, and to go from degrees to radians, it's the inversion of that, it is pi over 180. Bearing in mind that there are going to be a lot more degrees, the answer will be a bigger number in degrees than it will be in radians. This will make that number much bigger than that number. 180 over pi is like 180 over 3, which is almost like multiplying by 60. And as we found out before, that there is just under 60 degrees to 1 radian. So you want your degrees answer to be many, many times, close to 60 times, whatever the radian one is. So if looking at this here, we're going to expect an answer of probably 60 times that is just over 100. So probably around about the 100 mark as an answer for that. Okay, so that's got to be in your memory bank somewhere and to be able to recall it at all times. And that allows you to do both of these types of questions. So we're going here to convert 2 degrees from radians. C stands for circular measure. So we are actually going to multiply each of these by 180 over pi. So that'll be equal to 1.83 times 180 divided by pi. And when we do that, use your calculator, use the pi button on your calculator, 1.83 times 180 all over pi, and we get an answer of 104.85. Now that was fairly close to what our prediction was. It's roughly going to be 1.8 times 60, close to 2 times 60 is 120, so it's a little bit less, around about the 100 mark. So just put 1.83 times 180, divide by pi in your calculator, and that should suffice there. Once again, here we go. So we're going from radians to degrees, so multiply by, so we've got pi on 3 times 180 on pi. You can use your calculator, but probably it's just as easy to do it without here. We've got pi's are going to cancel, go into pi once, so we put little ones there. 3 is going to cancel with 180 as well, so 3 into 3 goes once, 3 into 1, 3 into 18 goes 6, 3 into 0 is 0. Multiply out, 60 times 1 is 60, 1 times 1 is 1, so that'll be 60 degrees. So pi over 3 radians is equal to 60 degrees. These examples, we're going from degrees and we want our answer in radian mode. So it'll be much less than that. It's almost like dividing by 60. So 1 point something, we might be close to this one up here. So let's do it. So we're going to multiply by pi over 180. So 100 times pi over 180. Now, when we're going back to radians, if you can give your answer as a multiple of pi, so just leave the pi in the answer and cancel down the fraction or the numbers over here. So we know 10 will go into top and bottom, just to cross off the zeros is the same as dividing by 10. And then we go, what goes into 10 and 18 evenly? Well, we'll try 2. 2 into 18 goes 9, 2 into 10 goes 5, and there are no more factors of 5 and 9. So we'll just say that that's 5 times pi all over 9. Multiply out the tops, multiply out the bottoms. Or another way of writing that is 5/9 of pi. 5/9 is close to a half of pi. So there we go. That's a good answer. That is the exact answer. If you did 5 times, use the pi button on your calculator and divide by 9, you'd get a decimal. And that's an approximation because you'll have to chop off the decimal to a couple of decimal places, and then you actually lose some of the accuracy. So if it is nice and neat like this to give your answer with pi, leave the pi in there, and that's the exact answer of what 100 degrees is in radian mode. So we'll put circular measure sign up there. 270, we know we're going from degrees to radians, so multiplied by pi over 180. So we've got 270 on 1 times pi over 180. We'll look to see if anything cancels. Once again, 10 is going to go into both. 3 will go into both, but something bigger than 3. 9 will go into both. 9 to 18 goes 2. 9, 27 goes 3. So that will be equal to 3 pi on 2 radians, or 3 on 2 pi radians. Either one. Doesn't matter which one of these two you give, both are exactly the same. So there's the conversions from one to the other. Be very fluent at those, practice them a lot. There are some you should know, some equivalents, so radians, these you should know off by heart. 30, 45, 60, 90, 180, 270, and 360. So all of those we should know by heart. And I'll just write them down. Pi is the same as 180. This is a sixth of 180, so it'll be pi on 6. So don't forget, pi is the same as 180. So we can use that. So if this is 30 is 1/6, so we just write pi over 6. 45 is a quarter of 180, so this will be pi over 4. 60 is 1/3 of 180, so this is pi over 3, or 1/3 of pi, because 60 is 1/3 of 180. 90 is half, so it'll be a half of pi. Another way to write half of pi is pi on 2. 180 is just pi. That is the basis on which we used to do the conversions. 270 is like 1.5. If you get half of 180 and add it on, you get 270. So 1.5 is like 3 on 2. So that'll be 3 pi on 2, which is 1.5 pi. And 360 is double that. So we write double pi, which is 2 pi. So these ones here, if you can remember 180 is equal to pi, you don't have to memorize, but you should be able to write all those down. If you do memorize them, it makes a lot of the work we're going to be doing a little bit later in this course much easier. So commit those to memory, and also be very fluent at doing conversions by knowing this conversion up here.